Hi, thank you for tuning in. My name is Kathy Grinnell, and I have a passion for making math make sense for kids. My focus on intermediate math, 3rd through 5th, and today I'd like to talk about the 5th grade standard, multiplying fractions by both whole numbers and fractions. I wanted to spend a little time making sense of that standard with you and the connections that you can make for students. And then I also would like to share with you an activity that you could do with your kids to help develop that understanding. So, the standard that we're looking at today is 5NF4. Apply and extend are the first two words that I notice. And to me as a teacher, that tells me that students are coming with some multiplication and fraction understanding, and my job is to help them apply it and extend it. So that's an important concept. 3rd grade, they worked with multiplication with whole numbers. So I can apply and extend their understanding of multiplication with whole numbers. 4th graders extended that to fractions. So they can take a whole number and multiply that to a fraction and understand that through repeated addition. I have 3 groups of half. Then 5th grade takes it to the next level, and they can now see that half of 3 means something different, but we're also going to get to the same answer. And then 5th graders can also apply then fractions times fractions. So truly, as I get ready to work with this standard with my students, I really want to make sure that I help them make connections, and I really want to make sure that they understand what's truly going on. And I help my students truly understand what's going on with math by asking them usually 2 questions. When we look at a symbolic equation or representation, I ask them, what does that mean? What does it mean to multiply? What does this number look like? What does a half mean? So really that meaning is important. And then also, this isn't brand new learning. This isn't, I get to show kids how to multiply fractions. They already have some understanding of multiplication and fractions. Your job is to make that connection for them and meet them where they are. So an activity that you could do is put a piece of chart paper up, give them a learning goal, which is our standard, just more in Kent-friendly language. And then we're going to start asking questions. We're going to show an equation. I'm going to ask the kids to tell me, what does that mean? What does it look like? And we're going to go through a sequence of problems to also look for patterns or structure. So the first problem that you could ask your kids is, well, if this is talking about multiplying, let's make sure we understand what it means to multiply. So going back to what you did in 3rd grade, you might have seen a problem 3 times 2. Well, what does that mean? That means I'm going to make 3 groups or sets or boxes or 3 groups of 2. Okay, that has some meaning behind it. I can start to form a visual of that, 3 groups of 2, which means I have a unit of 2, and I want 3 groups of that unit of 2. And the result is 6 individual items. Kids can stop, kids can make connections, you can listen to them, make sure they're understanding. Then I would ask them 3 times 1. What does that mean? What does it mean 3 times 1? That means I'm looking for 3 sets. It doesn't always have to be groups. 3 sets of 1. Okay? I have a unit. What is the size of my unit? It's actually just 1 item in it. We can add context. This might have been a box of shoes. This might have been a box of a unicorn or whatever one thing in it. I want 3 sets of my one-sized unit. Equals 3. Now I'm not sure if you hear some of the language I'm using already, but it's setting the students up for the transition into fractions. The first factor is how many copies or groups or sets of this group size. Okay? So now as we transition into maybe a fraction, 3 times half. Okay? Same questions. What does that mean? 3 groups, parts of half. 3 groups of half. 3 groups of half of something size half. Okay, so that this is my unit. I've got something. How big is it? What's the size of this unit? It's a half, so it's not even a whole. It's this half. And I need 3 pieces or parts or groups of that. Here's my multiplication. Equal groups of another half. Put context in if students are not connecting. I have half a gallon of juice. I drank it for 3 days in a row. Half gallon, another half gallon, had to go get another gallon, drank another half gallon of juice. Did that 3 times in a row. How much did I drink? I drank 3 half gallons. Now, what if we switch to the commutative property? This is 3rd grade. This is 4th grade. 5th grade needs to be able to see it in both directions. So if I switch the order and I write half times 3, I'm still going to ask my students, what does that mean? I want them to discover that it's the same answer as our 3 times half. But it looks different. So what does this mean? According to our order of our fractors, half of 3. So I want half of something that's size 3. Now I left the word groups out of this one. If we added it back in, half groups of 3. That doesn't sound as natural to us with the language. When we're dealing with whole numbers, 1 group, 2 groups, 5 groups, that makes sense. Half groups is a different way of thinking. So, a new language transition to bring in for your students is what John Vanderwall talks about, the meaning, the true meaning of our 2 factors in a multiplication problem. And he talks about the first factor describes how much. How much do we want? Half a group? 1 group? 3 groups? How much? The second factor always tells what. And our word of still fits right here. So anytime we have a multiplication problem, the first factor tells us how much of what. So let's go back up to our whole numbers. Does that make sense? How much? 3 groups of what? 2. Okay, 3 groups or 3 sets. How much? I want 3 copies of what? Something that's just one thing. How about this one? How much? I want 3 groups, 3 copies of something that's size half. Of what? Half. Oh, I want 3 pieces of a half size of pizza. How much will I totally have? So when we switch our factors to having the fraction first, this language is a little bit more natural. How much do I have? Half of what? 3. I can draw that. This is my unit, same as up here. What do I have? 3. And I want half of it. I don't want copies anymore because I don't have a whole number as my how much. I now have a fraction as my how much. So I want half of this unit size. So I could either cut it across, maybe, and students would see that there are 3 halves. Which is the same as here. They might also see it, they might have cut it down the middle, and where they would describe that I have a whole 1 on this side and half on the other side. How about half times 2? Talk about the language. What does that mean? What does half times 2 mean? Well, it means how much I want half of something that's size 2. Half of something that's size 2. So here's something, it's size 2, and I want half of that. So this one, I'm going to go vertical. Half of it would be 1. One item within our original size set. How about half of 1? What does that mean? I just said it as I wrote it. It means I want half of something that was a size, half of unit size 1. This is another language that you could hear. I want half of my unit, but my unit is size 1. So I want half of that, half of the item within the set. How much of what? We want half of something that's 1. This then transitions beautifully into a fraction times a fraction. If we ask the students what's half times half, and I ask them to tell me what that means, so we would say that means half. I want how much? I want half of what? Of something that's already half. Well, what does that look like? How can I draw that? So my unit is filled with something that's a half. Put context, right? Maybe this is my pizza left in the fridge, half of it's left, and I'm going to go eat half of it. So now that's this lighter blue part with the dark blue. So I can see that that's one piece, but we want students to name it according to the original item within the set. So we have one piece, what is that piece called? 1 out of the original whole, 4. So these sort of activities I really like because they help students to make sense of the math that we're giving them. It meets them where they are. It connects to the math they already know. It connects to pictures, and letting them explore, letting them play in this. Do this activity several times. Pick different series of numbers. Maybe you could do 2 times a third, or 10 groups of a fifth, or find easy compatible fraction numbers. But let this experience happen over and over again. Don't rush it, don't push it. I get so excited for my students to find the connection, to find the shortcuts and the rules, but I've learned that if they don't find it, then they don't own it. And many times I've had students come up and go, Miss Grinnell, oh my gosh, did you know that I just have to take the big number, the whole number, and times it towards the numerator? Because that's just how many pieces. And yes, I didn't know that. Oh, really? But that student is passionate, that student is excited, and that student has made sense for themselves how this concept works. So I encourage you to let your kids play, to help them find connections between the different pieces of math, and to make sure that they can represent what it looks like and what it truly means. Thank you so much for your time, and I hope everything goes beautifully in your classroom, and I'd love to hear about it.